All right, so today I will present Vanus. Vanus is an open source project that we are working on, and it's amazing. So let me share it with you. And so first, I want to introduce Vanus. Vanus is an open source serverless event streaming platform with built-in event processing capability. It can connect SaaS, cloud services, and database to help user build next generation event-driven application. So basically, Vanus is kind of like the middleman, which can connect your application or a third-party application to your application or to create an event-driven system. Let's say for you to get notification from a different application to another. That with no code. So here, let's talk a little bit about the architecture. I just want to get a little bit in. Just 1 second. I'm letting someone in. Okay, so I just want to share with you like some different parts of Vanus. I don't want to go too much in detail today, but we're going to have more in detail talks about the architecture of Vanus in the future. So here, first of all, connector orchestration system for automating deployment. So Vanus uses Kubernetes to deploy. It's in a container. And here in Vanus, you have the core system of Vanus, which has the computing function of Vanus and the storage system. The storage system has a container-oriented multi-level storage system. That means that Vanus runs on multiple containers at the same time and can run on multiple servers. So let's say you can have your event in your base server, and then you could offload also your events into, like, for say, an S3 bucket, which is can be bigger and smaller. Letting someone else in. All right, so here that's Vanus Core. Vanus Core basically does the computing and the event storing. And here we have the Vanus Connect. So in Vanus Connect, we have the source connector and the sync connector. The source connector will receive the events from different application. Might be your own application, or it could be like we have connectors like MySQL, Amazon S3, and so on. And then the sync connector is basically the consumer. It's the one who will receive the event after it's been processed by Vanus Core. Let's look the features more in detail. So the first feature in the core of Vanus, we have separation of storage and computing. The separation of storage and computing brings the ultimate scalability to Vanus. It uses multiple RAF algorithm to ensure strong consistency of cluster data. And what does that mean? Like RAF group, I'm not sure if you guys are familiar with that, but basically our events are in different cluster, in cluster 1, cluster 2, and cluster 3, or store 1, 2, and 3. And basically, let's say if one store fails and shut down, the RAF group will take the events and make sure that cluster 1 and cluster 2 can take care of the events. So you will never lose like consistency, or you're never going to have problem losing data. And also event computing, and then the data will pass to event computing. And one of the really good feature of running into Kubernetes is that the application, we can multiply the application. Let me get someone else in the meeting. So we can multiply the application, whether it be sync or the receiver application, in the Kubernetes environment, so that the output, like let's say if there's 10,000 events, if there's 100,000 events, there won't be any lag. But if there's only a few events, then we won't run as many container and as many applications. So it's truly serverless. And basically serverless means that if there's a few events passing, then there will be less cluster, there will be less application, and it will use less resources. But then if there's more events, then it will grow itself and it will use more resources to send the event in time. So there's no lag, and there's no and you won't need to run like a full-blown like server the whole time. That's what serverless is. Like if you run a big server, then it will cost a lot of money. But if your server can be flexible, it's more you pay as you use, basically. Our next feature I want to share with you is cloud Cloud Events. Cloud Events is original hosting project of the CF font. It improved the interoperability between different application systems and platform, and has become the standard for cloud native application event specification. So basically, there was a problem when we build application that sends events is basically that every programmer, they would make their own specification or their own way of sending the data for each application. And the problem is that when you try to connect multiple applications together, that were not originally planned to be connected together, then you have to make a program to be able to do that. Like you have to build your own logic for each application. And what Cloud Event is doing, and Cloud Event is another open source that us at Vanus we believe in, is that it's making a specific way of sending cloud events or events, and in a way that all application can talk to each other. So, for example, Vanus is cloud native to the cloud events. So let's say if an application is also cloud native, Vanus could send the the event directly to the application. And also Cloud Events is accessible. So basically, so many people are joining in. All right, so so Cloud Events are accessible to programmers because it can be written in Go, JavaScript, Java, C#, Ruby, PHP, PowerShell, Rust, and Python. So basically, they have SDKs for the Cloud Event specification server and client for all these languages, which Vanus uses. So let's say you build an application in Java and you want to send event directly to Vanus. You can use the SDK of Cloud Events and then send the events. And if you don't want to do that, you can use connectors. So let me share about Vanus Connect, the connectors. Vanus Connect allows to skip the complex integration with external services by offering out-of-the-box connectors. Each connector acts as a proxy between outside services. So basically, the source connector will grab the data from, let's say, MySQL. Let's say there's a new entry. It will be written in the bin log. And then it will grab that information, transform it into a cloud event, and then send it to Vanus. Then in Vanus, what you'll be able to do is, first of all, store it in what we call an event bus. That's where you store your data. And then afterwards, you'll be able to process your data how you want, and then send it to a sync connector, which could be your own application that can receive cloud events, or it could be a third party, just like Mail, or another MySQL sync, or so on. It could be Slack also. And so how does this work? How are you able to take an event from Vanus core and then send it to the sync? For that, we have the subscription. So basically, once you have event, you have let's say you have your connector, your source connector running, and you have your Vanus core running, and you have your sync connector running. Now you want to make a subscription to be able to take the events inside your event bus and to send it to your sync connector or to your sync application. So guys, please mute yourself while we're having the meeting. We're going to, it's all right. All right, so VS Control subscription create. Using subscription create from VS Control, we can subscribe to an event bus and specify where, what, and how to send the events. So for example, here we have an event, a subscription. We set the name of the subscription, the event bus name. So first in Vanus, you can create an event bus to send the source connector's events to the event bus. Then afterwards, you're going to specify the sync. Sync, like I said, can be a connector that's already made, or something that you have code that has a server, a cloud event server. You can also set, which is optional, max retry attempt. If the sync connector server is not connected to the internet or fell, how many times should Vanus try to send the event to it? After 5 times or 10 times, the rate limit, how many event do you want to send in a second? So do you want to send 1,000 event, 10,000 event? Depending on the way your application is made to receive event, you can set the rate limit. You have also delivery timeout and from earliest or from latest. So basically, you can choose when, from where do you want the subscription to read the event from the event bus. Do you want it to be from the earliest, the first message that was sent, or the event? Then we have filter. Filter allows you to filter events from event bus when creating a subscription. Filter types like exact, prefix, suffix, not, all, any, and SQL. And I think that's a game changer in event-driven application. The ability that your middleman, even though you can't control the events that are coming in, you can modify them and control them with Vanus. So first of all, you can use filter. And because our events are in the JSON format, you can choose like the path, so like the type. And if it's exactly like for example, here we have object create. So only the object created in the Amazon S3 bucket will be the event from the created object are going to be taken by the subscription. So you could have another subscription for the deleted event. And that way you can choose how you modify each type of event. And so here, after here, you can transform the event. And so first we have define. The parameter define is used to define variable using JSON path to reference items in, sorry, you're unmuted, Jay. Can you mute yourself? So yeah, the parameter define is used to define variable using JSON path to reference items in the cloud event and store those value in variables. So basically, let's say, for example, you have an event coming that has like really simple, like a name and like the date, like how old the person is, like name, Michael, age 30. And so it will save this information for each event. And then if the next event is like Jay and age 30, and then you can make a template and say, his name is Michael, his age is 30, and so on. And so this way you can modify how you want to send your events. Like, for example, recently I wrote a blog about taking events from a MySQL and then transforming them so it would be readable for the sales team, so they can know about the entry in the MySQL. So this way I could take the important information and leave out the information that was not important and then create a template, which you don't need to do, but you can do. It's a feature. It's the define and template feature. And then lastly, we have pipelines. And before in my, we were planning to have more than 50 possible function. And a function like create a new event attribute or data path, rename attribute or event data path. So you can rename, create, delete, join, replace, and so on. And there's many more. And going back to this, you use the pipeline to help you define function. These functions can create, delete, move, rename, like I said. So you can really modify the event. So for example, let's say you want to send an event into the email and you need to define the receiver, the person that you're going to send the email to. So to do that, you're going to use a command to change, to create a new field in JSON and then to add the email. And what's really cool about that, you can use define to get the email inside the event and then move it to another place to be able to work with your next application, which could be email sync. And so that's what Vanus is in a short time. And I'm going to let, well, first of all, thank you guys for listening. And I'm going to let Jay start his session. He's going to share how to build a sync connector with you guys, showing some code about Golang. I hope you guys can stay. And we're going to have a Q&A after this. Thank you guys for listening.
Okay. Hello, guys. It's so glad to see you here. I mean, okay, sorry. Okay, before I start my coding session, I do want to remind you one thing that Okay, let me share my screen.
Just 1 second. Okay. All right. So you can share your screen.
Okay. Okay. Now, please do remember to sign here, like if you attending in this meeting. So, like after this meeting, we can have like a summary to know the people who on the list attend our meeting. Because after that, we'd like to give like the contribution points based on your attendance about the every weekly meeting. Okay, that's something I like to remind at first before my coding session starts. So thanks so much to Michael about this. Amazing sharing about Venus. I'm so happy to hear that. And for my session, it's mainly about the coding part. But like my session will mainly consist of 3 parts. First one is what is Venus Connect, and then there will be a online coding session about how to write a Venus connector with our CDKs. And finally, I'd like to share you guys with some like future plans of our Venus community. Okay, let's move to the first part. What is Venus Connect? Basically, Venus Connect allows you to skip the complex integration with external services by offering out-of-the-box connectors. These external services can be everything like the SaaS applications, message queues, databases, AWS services, anything you want can be your external services connected by our connectors. And each connector will act as a proxy between these external services and your system, enabling you to have faster integrations without writing any codes. And generally speaking, there are 2 types of connectors. One is a source connector. A source connector will obtain data from an underlying data producer and deliver those data to its targets. And all original data will be transformed into cloud events before they will deliver to the targets. And a sync connector will receive cloud events and does some specific business logics. For example, if there is a MySQL sync, it should extract the useful data from incoming cloud events and write those data to a table in a specific like MySQL database. And so, how indeed like a developer can contribute to Venus and write a Venus connector? So first of all, you should go to the Venus connector repo. Here is a link. Let's go our Venus connector repo to have a look at it. Okay, this one is the Venus connector repo. So click here, issues. You can list all available issues, but before see everything, we'd like to use a label like Venus Connect. With this label, you can just filter all Venus Connect related issues. And for this demonstration, I just created a new one like this one, the test issue. This test issue requires me as a new developer for Venus and to create a sync connector, which is the circle. Okay, let's go to this issue to have a look at it. So this issue consists of 5 parts. The first one is what is a Venus connector, and the second one is what is a sync connector. These definitions I've already mentioned in previous slides, so I just skip those kind of things here and move to the third step. Features of this connector. This one is actually the most important one in this issue because we like to use these features of connector to tell you what kind of connector we'd like to have and what sort of features these connectors are supposed to have. So actually for a mature Venus connector, there should be like many features for this connector. But for this example, I just select one of the most important one, which is allowing users to insert a new row on a MySQL table based on the incoming cloud events. So how can we create a new connector? first step is to fork the Vanus Connect repo. I guess you all guys are quite familiar with something like this as long as you are familiar with GitHub operations. And then create a proposal. Actually, under our Vanus Connect repository, there is a directory called proposals. In this directory, there are two types of proposal templates. One is the sync proposal example.md, another is source proposal example. You can choose which one based on the type of the connectors you are writing. So once you copy this example, and you should, inside this proposal, you should in detail tell us how you'd like to design this connector and how would you like to implement this connector. And then submit your PR about this proposal. Once the PR has been approved and merged by the maintainer team of Vanus Connect, you should go to the next step to code. We just don't want to waste your time. Like if the PR hasn't been merged by us and you already start coding, it's gonna kind of waste your time. Okay. So if you can go to the, once your PR has been merged and you go to the next step to start coding, you can choose one of our coding templates, the language specific templates. One is written in Golang, another is written in Java. And these two templates are provided because we want you to avoid start coding from the scratch, just speed up the whole process of developing a connector. And then once you copy this template, coding-based templates to your local, and then you can implement your connector and submit a PR. Finally, just await the PR to be reviewed and approved. And congratulations, you can become the Vanus Connector contributor. And the last thing, how you can claim that you want to implement this connector, because if so many people are trying to claim they both want to implement one, we are trying to avoid such kind of conflicts. So it's quite simple actually. You just leave a comment, something like "I'd like to implement this connector." Leave a comment like this, and the Vanus maintain team will see that comment and assign this issue to you. And if other people also want to do this, we will suggest them to switch to another open issue. Okay, that's something about how to assign some issue to yourself and how to start contributing to a Vanus connector. And now let's move to the online coding sessions. This quite I'm not sure if it's challenging to me, but okay, I'm gonna share the screen about a Golang template. Before start coding, I like to introduce the structure of our Golang template. So there are two directories. One is called CMD, another is internal. In this CMD directory, there is a file called main.go. This main.go is actually the entrance of our connector program. And in the internal directory, there are two files. One is config.go, another is sync.go. And then this config.go consists of all things about the user configurations, and the sync.go consists the implementation of this sync this sync connector. Okay, so let's look at the main function. We all know that the main function should be the entrance of all kind of programming language. So we provide a CDK in Go, which we call the CDK Go, and we use a method run sync to run the whole connector. And this run sync method requires two arguments. One is new my connector config. Another is new example sync. These two arguments are actually two functions, and let's look at it. This function actually returns a struct of the example config. And this example config is used to add all add all configurations, you need pass from the connector users. Let's say I'm writing a MySQL connector. So if someone is trying to use my program, absolutely the users should pass me some configurations like the host, like the DB name, table name, maybe username, password, something like that, all configurations. And these configurations can be written in this struct. Okay, so let's start from this part. Once you got something like here, actually you can refactor this struct to rename it in whatever you want. Okay, maybe you can just rename now. So let's call it my circle config. So the struct will be renamed as MySQL config. Once you download the template, you can also do this. Now, I'd like to insert a custom configuration, which I need from the user. Basically, it's all DB related ones. So I'm going to create a new struct to just encapsulate all configurations I need. So I'm going to create something called DB, and this one is a struct. And I'm going to make a little bit copy here to save my time. Okay, so for this part, I'd like to explain a little bit like here, the host string. Basically, I created a field called host, and I also give a tag here, so the CDK can actually extract the configuration value from the configuration files. So the CDK will actually get the key from in a configuration YAML, which the name of the key is host, and assign that value to this host field. So I'm gonna copy something like this. I'm just gonna list some examples like host. Let me have a look what kind of things we need actually. We need host, port. We need host, port, username, password. Okay, so port, we also change the tag. Remember, you have to be like consistent with the tag and the tag and the configuration key and username. Also change the tag here to username and password. Cool. So also I think we also need a DB name because we need to connect to a database, right? DB name. Okay, just to make sure the K is okay. So there's a inconsistency. We all use something like this. DB name, okay, and also another last one is a table name. I'm just gonna copy this one. Now we just create a new struct about our configuration struct, which we call it DB. But how this DB struct can connect it with this MySQL config, we didn't connect it. So now we create a new field, maybe called DB, and the type will be the DB we just created here. And also we're gonna give them the tag so the configuration can have a mapping here. Yeah, cool. So if we go back to have a look at it, here is a struct called DB, and its tag is also called DB. If we go to the config.yaml, we can clearly see there is like the first level struct object is DB, which can map corresponding to that config struct DB. And inside this DB struct, there is like host, port, username, password, DB name, table name. All these fields will be reflected to this fields I created here, and the values will be assigned to these fields inside this struct. Okay, so now we just create a MySQL config. You can do whatever you need. Like if you are writing a AWS S3 source or sync, maybe you need AWS credentials here, so you can put those credentials inside here instead of MyDB. You just need to add your custom configurations inside this struct. For me, it's MySQL config struct, and for you, maybe AWS S3 config or another Google Sheets config, something like that. Just put your custom configurations. And now we go to the main implementation of our connector, which is this sync.go. And in this sync.go, remember when we have this main function, there is a new example sync function. This new example sync function will actually return an instance of this struct example sync. Okay, this example sync, we can now also refactor it, rename it as what we want. For me, I like to call it MySQL sync. MySQL sync, okay. Okay, there is a refactor. Okay, cool. So just rename the struct. We call it MySQL sync, right? Also, what we need to do, we need to like we can add whatever we want inside this struct. If you need something like the other APIs from other like SDKs, maybe Google API or AWS API or some driver like the database driver, something like that, you can just import those things, import those types into this struct. For now, I'm just doing an example, so I won't go that far. And the first important method we should care about is this initialize method. In this initialize method, you can basically do whatever you want to prepare your connector. Like all things which has to be like run once, you should put inside this initialize method. Just do something like the preparement. So for now, I can get my config from here. And what we're gonna do, let's just have a look if we can successfully get all values from our like configuration files, because in the future these configuration files will like fill out by our real users. Your program, your connector program, need to read the value from this configuration file, right? So we just have a test to see if we can receive these values. And okay, so let's try to with a really simple one. We just print out the config dot. Remember how to get the value of that? First you dot config, and then you go to the DB, which is a struct we created before, and then we just created this host, and now we can run this connector. Have a look, run a little bit to see if we can get the data of this DB host. Okay, go run. You can have a look at my screen. This command I'm trying to use is to how we can run our connector locally. So you go run, and as I mentioned before, the entrance is main.go. So it's just go run cmd/main.go. Okay, you can see here, this is a string I'm trying to print out, right? So because in this configuration file, I gave the value localhost to the host, so I can easily get every value I need in this method, right? So here I just simply print print out one field, maybe host. If you want, you can print all things, or maybe you can like create a new pattern of the string. Like when you are doing a real DB connector, you have to like make a DB source, something like that. Maybe username, password. You need to construct a string of that. You just need to use all fields of that. So you can like from here I can just print out another thing. So DB, we just print out another like maybe username. Just have a look at it. Yeah, you see, we got the host is localhost and the username is root. So from this part, you can just use all these user path configurations to get the value from user, and then your program can do all business like your business logic based on these configurations passed from the user. Okay, this is how we can use this part from the initialize method. That's one of the most important methods in the connector template. Initialize. Remember, this method will be called once, and all your pre-parent methods should be placed under this method. And then I'm gonna quickly going through several methods. This name will return your name. So here I return my circle sync, and this destroy, you can like release some resources. Like if you create a DB connection, then you can like close that DB connection here, like in this destroy method. And now we come to the most important one, arrive the method. This method is to like deal with the incoming cloud events. Remember, before doing the real implementation, I'd like to remind you about the concept of sync connector. The sync connector will receive incoming cloud events and like extract some useful data from that incoming cloud event and use those data to do their specific business logic. So here in my MySQL sync, I'd like to create a method called add event to table, which requires one argument that is a cloud event, right? So I'm gonna do something with this cloud event, and inside this method, you can see here this is a for loop, right? So you don't need to care about where that those cloud events coming from, because the CDK will handle all these like traffics or HTTP server. All these things will be handled by the CDK. So you only need to implement your business logic here to do whatever you want with the cloud event. So I create a new method called add event to table. Basically, I want to do something like with each input event, I want to make it create a new row in MySQL and insert that row into a table of a MySQL database. That's what I'm trying to do here. So, okay. So now I'm gonna, because the whole process will be too complicated, I won't go that far here. So I'm gonna just doing a little bit really simple one. Like I'm gonna show you how to see all data inside a cloud event. Okay, I think that part will be most important one. And after that, you can decide what kind of operations you'd like to do with those data. So most important one is to have a look at those data inside the cloud event. Okay, so let's start. And we can use the event. This is a argument passing from this method, right? Event.data will get a byte array. So how can we do this? So we can create something like this. Like we can make we can, because this is a byte array, so we better make a map to help it. This map, the k will be string and the value will also be string here, and we'll create this data row at this map, and then we need to unmarshal. If you are not familiar with Golang, this part will be a little bit hard for you. But this unmarshal method is trying to like transform like all data array into a pointer, which will be our data row, new created data row. So from here, this data row, we just create a variable data row, and that's a map. And we use map to allocate the memory for this map. And then we use unmarshal methods to give a specific byte array inside this data row. So now this data row will have the data inside it. So now it's gonna be easy for us to have a look at the data. We just use a for loop to print out everything, and I won't go so far to deal with. So we can just I'm gonna just print out, okay? Print out K and space, and also print out V. So now we can, maybe we also should to give an error to it if the unmarshal returns something like wrong. If error is not a new, we better just throw a error, fatal error there. Okay, cool. So now we're gonna for loop like to iterate everything inside this map, and we're gonna print it out. So let's have a look at it. Okay, now the connector is running. Currently, it didn't show anything because remember I told you guys the incoming cloud events will be like showing here, but for now we didn't send anything to our connector. So here I'm gonna use a cur command to create a cloud event. You can see this is a cur command. I'll use a post method to specify to send the data to localhost 8085, which is my connector port. And then I create a cloud event like this. This is a cloud event specification format. If you are not familiar, you can go that later. And the important one is this one. This one is the data part. I'm trying to send this data. All the data format is like a key value pair. So it's ID something, name something, description something, date something. So all these things are key value pair, right? So just send it to our connector and to see if we can. Okay, here you can see our connector successfully received this one and print it out. So it's name, XDL, description something, date something, ID something. Basically, you get everything from this incoming cloud event. And my coding session will just include this part. And after that, you can do like much more complicated operations. Like you use this data and extract this data and insert them into a DB row. That like involves something about the operation with database. I won't go that far in this coding session. Also, I think I already used so long time to introduce this coding session. So I'm just gonna stop the coding session here. And I'm gonna move to the last part I'd like to share with you guys. Okay, so which is some future plans of our Vanus community. The first plan for us is to create a Vanus Connect SIG. SIG indicates the special interest group. And for all contributors who are interested in Vanus Connect program, they can join the SIG to discuss how to write or how to use these connectors with other developers over the world. And contributors with remarkable contributions will be selected out as members of the Vanus Connect maintainer team. So they can help us to make decisions about Vanus connectors. Basically they will be in charge and have a lot of rights to do something, to make some decisions about the Vanus Connect program. And then Vanus Connect ICIG members will be displayed on our website with their profile and contributions. Also, this part is totally based on personal willings. If you'd like to show it on our website, we are happy to do that. If you prefer not, we will not force you to do that. And the last one, Vanus SIG members will get swags and other rewards regularly from our community, because I don't know how many you guys know we have the top contributors event in 2022, and there are top 10 contributors. They all get the Amazon gift cards as their rewards for that event. So we for all members, we will regularly get swags or other rewards from our community. The second plan is that we'd like to publish a connector contribution program. This is the most important contribution program this year for our community. Basically, contributors who write connectors for Vanus will get contribution points. Contribution points are quite important in our community, and I will talk the usage of the points later. And even some cash rewards. Remember, you can even directly get cash. This time maybe you don't get Amazon gift card. You directly get some cash rewards. And secondly, contributors who write connectors can have vote rights in our Vanus Connect meeting. We will also, like today's meeting, we will also hold Vanus Connect meeting regularly in the future. And those people who join the ICIG and who write the connectors can have also have the right to make the decision about other connectors. And the third one is contributors who write connectors can join the Vanus ICIG first, because recently we already received many requests from our developers who want to join the ICIG, because they see there are a lot of benefits from the whole open source community perspective. So the contributors who already contribute a connector to our community, to Vanus Connect, this program, will have the first chances to join the ICIG. And the last plan will be the contributors points system. As I mentioned before, each contributor who participate in Vanus events or contribute to Vanus will get contribution points each time. And these contribution points can be used in other events. And this time we will also design a contribution levels based on that points. So if you got 100 points, maybe you are level 1, and 200 points, maybe level 2, some just the levels in the game. And the contributors with higher levels can get higher benefits from Vanus community. Contributors can also choose if their level or other information to be displayed on our website or not. It's totally up to the personal willings. Okay, I guess I can extend my session time. Sorry about that, but I'm really happy to see you here. And next, I guess I will return to Michael.
Yeah. So first of all, I want to sorry. First of all, I want to ask you guys if you would share with us where did you heard about the meeting inside the chat. Just write down I found the meeting on the Slack channel or so on. Where did you find a meeting? We just like to know, to see where is the best place to share the meeting in the future. So please do. And now we're going to go to a live Q&A. So if you want to ask us some question, Jay and I will try to answer our best. If you want to ask a question, let's say maybe you can raise your hand. Or actually you can write in the chat that you want to to ask a question, and then I'm gonna call you, and then you can ask the question. So like that, we can I don't miss anyone. Yeah. So if you have a question, please just say I have a question in the chat, and I will name you, and you can ask your question. Just in the yeah. Cool. Anybody has a question?
Yep. Any like further questions about no matter the community or other events you like you are interested in?
I guess you can unmute yourself and ask a question if you'd like to at this point. I mean, if it's simpler. Can they unmute themselves? Yeah. Oh, okay. A hiss? Oh, yeah. Oh, sorry.
Yeah, I mean, in the QA session, you can just unmute yourself and tell us what you want to ask. Maybe it's much easier for you to like, rather than typing.
And also, thank you for letting us know where you heard from this meeting.
Why are there two ports in the config file? Okay. That's about a connector demonstration. Okay, I'm gonna simply explain it because I'm writing a. Okay, I need to share screen to explain a little bit.
Did you make me?
Yeah, can you switch to me a little bit?
Yeah, no problem.
Okay, so he asked a question about why are there two ports in the config file. Okay, I guess that's about our first YAML file. So basically, you see here are two ports. One is for the connector itself. So this connector will listen on the port 8085. And this port is for the DB connection. So let's say you are connecting your MySQL server with the URL localhost 3306, but this port is used to like receive the incoming cloud events. So that's why there are two ports. And in order to like split it, that's why I create another level configuration, which the first level is DB. So this port will be DB port, which indicates the port is used in the DB connection, and this port is used for the connector itself. As if you have a look at here, when I send a cloud event to the connector to the MySQL sync, I use the localhost 8085. That means this one is a HTTP port, which listening this port. That's why there are two.
All right. Thank you, Jay. And so, yeah, if you have any question, please let us know. Like, you can unmute yourself to share your question, or you can even write it in the comments, and we will do our best to answer the question. Also, I want to mention that Veda shared our Slack link, and if you haven't joined, you can join us on Slack from that link.
Yeah, that's really important. Join our Slack community, and if you have further questions, you can also like discuss with other developers or other Slack members, or ask questions directly to us, like DM us.
Yeah.
What about for a live connection, inserting data to a MySQL DB? What will be the port? Live connection. Okay, like if you are trying to establish a connection. Okay, Jeff, I saw your question. Like, wait, I'm gonna answer this one first, and then I'll get back to you. So, if you are trying to establish a MySQL connection, insert data to a MySQL DB. Okay, still the two port question, like two port one, right? If you have a MySQL DB with a port 3306, you can just mention it, like use that port to connect to your MySQL server. But the MySQL sync itself, it needs a port to listen to listening on so that it can receive incoming cloud events. That's why there are two ports, and they are totally separated. Won't influence each other. So there's totally okay for that two ports. I'm not sure if that solve your questions here. And I'm gonna read a next question. About the Vanus function, I would like to detect bugs in core function code I write locally before pushing to a repo. I only know of using the Go test any other ways locally. Any other? You mean any other ways to run the the function codes locally? Okay. I like to detect bugs in code function code or write locally before. Yeah. Yeah. If you like to debug, no matter you are implementing a Golang function or something, you just download that the main Vanus repo to your local, and then you create a branch and implement your own, and just go test it. I know. I see that you are using the Go test. I think it's a good way to use a Go test to test through the function. That's also what we usually do with when we test our functions.
Thank you, Jay. So if you guys have any other question, like I said before, you can unmute yourself, ask the question live, or even write it in the comments. Yeah. We can answer a few more questions.
Yep. Any questions else? When is the SIG program starting? Okay, that's a good question.
That's a great question.
The SIG programming will start after the next week. So it's starting in 2 weeks. After 2 weeks. So because we still need to prepare some mechanism about the SIG, but we will pre-publish all